All right, so in this video, we are going to go over how to read an inverse function based off of a table. So we already know that an inverse function is something that takes your outputs and maps them back to the original input. But sometimes that can be really challenging to think about when you're looking at a table and you start mixing up, like, what are my x's, what are my f of x, what's f inverse of x, right? So I want to give you some visual tools that will hopefully help you and aid in this process as you're going through this. So if you're given a table, let's say this is your function with values 1, 3, -6, and 8. Those are your input values. And then 14, 5, -3, and 10 are your output values. And what we're going to attempt to do is create an inverse function table. So here's what I'm going to do for clarity. All of our function table stuff I will use with a black pen, and then red pen will denote inverse things, and I'm going to use the correct notation and everything as well, but hopefully the red and the black will help you to keep things on track. Okay, so what I would like to do first is kind of represent this more visually for us. So I'm going to write our domain here and just try to understand this as, a function that maps one set over to another set. So here's our domain. It has all the inputs, which are x values, right? So these are your x's, okay? Now over here, this is our range. These don't have to be squiggly shapes, but for some reason, math teachers always do that. Okay, so our range is all of our output values, which are like your f of x's, okay? And so then this would be all of the outputs, 14, 5, -3, and 10. Okay, so when you start mapping these back and forth using the function relation, that would look something like, okay, 1 goes to 14. Now the map that takes us there is what we call f. So it's a little bit weird, but like f of x is the number 14. F is like the travel route to get there. So we, f of x, it's very, very subtle, but f is like the function. F of x is the output itself. So that's why I'm saying this is, f, and these over here are my f of x's. These are my outputs. Okay, so if I wanted to kind of map this backwards, I want to start building my inverse relation, my inverse function, then what I'm actually looking at are these being mapped backwards. So I would take, I'm going to use red pen now, 14 and map it back to where it came from, which is 1. So along this path is my f inverse. That's my f inverse path. So what you might notice is that all of these outputs for my function are now inputs for the inverse function. And all of these original that were inputs are now outputs for f inverse. And it goes like that. So I listed all these in order already. So I know that 5 goes back to 3, -3 goes back to 6, and 10 goes back to 8. So now let's actually build our inverse function table, which I'm going to do right here next to it. Okay. Now this part is where I personally tend to get a little bit confused, which is why having, the visual really, really helps me, is that now these are what I call x. These are my inputs to the inverse function. And it's all these guys. Because remember, I'm taking these and mapping them backwards. So these are now my inputs, and these are my outputs. So my x values are 14, 5, -3, and 10. And my outputs for f inverse of x in order are 1, 3, -6, and 8. So 14 goes back to 1, 5 goes back to 3, -3 goes back to -6, and 10 goes back to 8. All right, now visually, if you want to pause the video and take a look, it essentially looks like we took these two rows here, flipped them over, and slid them this way. And that's essentially exactly what we did, but it just becomes confusing, especially for me, when I start looking at the X column, and I'm like, or the X row. I'm like, well, these were inputs, and now these are my inputs, and I just get a little bit lost. So a lot of times building some kind of a map to help me visualize what I'm doing can be really, really meaningful. Okay, so now let's actually use some of this stuff. Let's evaluate some type of a question they might give you. So let's say one of the questions might be something like, hey, what is F inverse of 14? Now, if you felt like your feet were under you until now, that's okay. Because I felt a little fish out of water when I was learning this too. Because now it's like, wait a second, 14, does that mean, does that mean it's not, okay. So I want you to think in terms of, we're now looking at this table over here. 14 is my input. So this is my X. And it's an input to the inverse function. So I am looking for it up here in the X column, and the output was 1. You can find it on your original table if you think of this as like, well, now I have to go backwards. I have to go from the range, the outputs, back to the input. So if you have a clear understanding of that, then awesome. So you can think in terms of, well, here's my 14 output. What was the input? Well, it was 1. So it's a little different how you read the tables. My brain personally feels a little more comfortable if I build my inverse table first, and then I can just immediately think, okay, 14 is like the X input, which is here. The output is 1. If I have to keep switching back and forth too much, I can get a little confused. All right, let's step it up a little bit. Let's say they're asking, hey, what is F of 3 plus F inverse of 5? So this is kind of like two problems together, and I have to use both tables. And this is where it could start getting a little confusing, so really pay attention as you go. F of 3, that's using my function table over here. 3 is the input, so what's the output? Well, I go here to 3, and F of that is 5. So F of 3 is the value 5. But now, what's F inverse of 5? So maybe you're really comfortable with this already, and you could say like, oh, I just need to look at 5 on the outputs and then map it back, and that's a 3, but I don't know, it just seems a little confusing to me, so I'm going to go to my inverse table and say, okay, where is 5 on the X? And then it maps out to 3, so 5 matches with 3. 5 plus 3 is 8. And so that would be your final answer there. So feel free to use maps, tables, or just internalize the concept and do it in your head. But this is essentially what they're asking for, to evaluate inverse functions using a table.